Hi, in today's video, I'll be explaining about SUVAT equations and projectile motion. The SUVAT equations describe motion under uniform acceleration. It is important to know that they only can be used when the acceleration is constant. S stands for displacement, distance in a straight line. U is the initial velocity and V is final velocity. A is acceleration and T is time, or the duration of the motion. We must also remember that displacement, velocity, and acceleration is vector, so direction must be taken into account. Here are the 5 SUVAT equations. They are all provided by the data booklet, so there is no need to memorize them all. Using these, we can find the others by just knowing 3 of them. When solving SUVAT, it is easy when identifying what is known in the question and what we have to find. Let's look at an example question. The first step we need to do is identifying what is given and what we need to find. Initial velocity is given as 20 meters per second. Time is given, and acceleration is given as well. I'm going to be putting them all as plus, as time is a scalar quantity, so there's no need to be a direction, and speed and acceleration is both in the same direction. As we need to find the displacement during this time period, we can use S equals ut plus half a t squared to find the displacement. Calculation is easy. We can do it by simply substituting the values in the equation. This question looks at the vertical movement of an object. We can first draw a diagram to visualize the question. The initial speed is given as 10 meters per second, and it takes 8 seconds for the ball to reach the maximum height and fall back to the ground. There will be gravity acting on the ball opposite to the direction of initial velocity, so we can put acceleration as negative 9.81 meters per second squared. We can solve this question by using S equals ut times half at squared. Remember that S shows the displacement, not the distance traveled by the ball, and the displacement is equal to the height of the building. Now let's look at projectile motion. This is when an object moves in 2 dimensions under the influence of gravity, such as throwing a ball which will move in both x and y directions. For these type of questions, we need to separate the velocity vector into x and y direction. The horizontal and vertical components in projectile motion share different characteristics. Assuming that there is no air resistance acting on the mass, the horizontal velocity stays constant, and we can simply use distance equals velocity times time to find out the displacement. Verticals are a bit different. There will be acceleration due to gravity, and therefore we must use the SUVAT equations to find out the details. Now let's look at an example of throwing an object from a cliff. We can draw a diagram to fully understand the question. The first question asked about the time taken for the ball to reach the ground. This will be about the vertical component of the object, and we have to use SUVAT. So these are the given informations. Initial velocity is 0 meters per second. The displacement required is 50 meters, because that is how high the object is located. Acceleration will always be 9.81 meters per second squared for free fall. We can use S equals ut plus half at squared and rearrange to find out the time needed. The second question is about the impact speed. Impact speed is the speed of an object when it strikes another object, like the floor. To find this out, we need to know both the horizontal and vertical speed when it is touching the ground, and use the Pythagoras theorem to calculate the impact speed. The vertical velocity at the end can be found using SUVAT equations. Using the same information from above, we can find using V equals U plus AT. Remember that the horizontal velocity remains constant as the initial velocity, assuming that there is no drag force. So the Vx at the end is also 12 meters per second. We can find out the final velocity using Pythagoras theorem, resulting in 33 meters per second. The next question is about launching an object at an angle. Initial speed of the object is given, but we need to split into horizontal and vertical components. The vertical speed equals to 40 times sine 30 degrees, and the horizontal is 40 times cosine 30 degrees. The first question is asking for how long the object will be traveling in air. We can think of this as how much time it will take for the object to reach the maximum height and fall down. It is easier to think about the time taken until maximum height, as that will be exactly the half of the total time taken. Therefore, we can use the initial vertical velocity, acceleration or gravity, and the final velocity, which is 0 meter per second, and calculate the time. We can use v equals u plus at and rearrange this equation to find out the time until the maximum height. For the final answer, we must not forget to multiply the value by 2, since the calculated value is only the half of the total time. The last question is about horizontal displacement. For this question, we have to use the total time taken and the horizontal velocity. The horizontal displacement is equal to time times horizontal velocity. So this will be the calculation. This is the end of today's video. Thank you for watching.